Good afternoon, class. This is another mini assessment session that we're going to use doing our Screencast-O-Matic. Today I'm going to go over our mini assessment that we used on January 22nd. The first problem states the National Directory of Magazines tracks the number of magazines published in the United States each year. An analysis of data from 1988 to 2007 gives the following computer output. The dates were recorded as years since 1988. Thus, the year 1988 was recorded as year 0. Excuse me. A residual plot not shown showed no pattern. There are lots of different ways that we can go with this information as far as what type of questions we could ask. We're given a date range. We're told us that we're talking about the number of magazines. We're told that 1988 was year 0. We're also told that the residual plot showed, even though it's not shown here, we didn't have a pattern. Now that's important when it comes to determining linearity. It is important for us to know that a residual plot needs to not have any particular pattern. So the first thing we need to do is we need to look at each of these equations. It says write the equation of the least square regression line. Identify any variable used in this equation. When it comes to analyzing this output chart, anytime you have your predictor, coefficient, constant, and years, couple of key pieces of information. This constant right here is always going to give us our y-intercept. And this value right here will always tell us our slope. And this value right here will always give us our r squared. So we're going to use that a little bit later on. Now, the equation of least square regression, remember, when it comes, our LSRL is used to make a prediction equation. So we often will use y hat, or in this particular case, I'm utilizing magazines. That's what I'm looking for. I can choose to put magazines hat, because again, that's the predictor equation, is equal to 13549.9 plus 325.39x, in which x is going to be the years since 1988. Now it says, what is the value of the correlation coefficient? Now your correlation coefficient is r. We were given r squared, and grading a couple of these, a few of you guys got this correct, and I do notice that a couple of you guys made one simple but easy rectifiable mistake. My r squared in this particular case is denoted as a percentage. We must first change that to a decimal, and from there I will figure out what my r is. So I will take my r, the square root of 0.848, which will give me my 0.92. So that right there will give me the my correlation coefficient. It's important that you remember the key vocabulary words. Correlation coefficient is your r. If they had asked us about the coefficient of determination, if they asked us about the variation, the percentage of variation, they're referring to your r squared. The next problem says predict the number of magazines published in the United States in 1999. So I'm going to use my prediction equation and simply substitute in those values. And because X represents the years since 1988 and 1999, that means that 11 years had actually passed by. And from there, we will simply substitute that in. I'll get my little handy calculator. And it will let me know that once I get this, I get 13,549.9 plus 325.39 times 11. And I end up with 17,129.19. And since we're dealing with whole numbers, I'll just say approximately 17,129 magazines. We can anticipate that will be published in 1990. Now, even though they didn't ask us about this, this is another typical question that they may ask. Suppose they asked us to make a prediction, or they questioned the validity of a predicted magazine amount in the year 2000, let's just say 2018. Looking at this, we would see that because our data spanned from 1988 to 2007, that would represent extrapolated data. And remember, extrapolated data is not the most reliable, so we would be hesitant to use this LSRL for that particular data. Okay? Again, that was not on the problem, but I need for you guys to be very conscious of I can give you the exact same data output and ask you various problems for it. So let's look at the remaining two problems. It says child development researchers studying growth patterns of children collect data on the heights of fathers and sons. The correlation between fathers' heights and the heights of their 16-year-old sons is likely to be. Now, this is where you're going to have to use your critical thinking skills. We're talking about correlation. It says near -1. That implies a basically near perfect correlation. Because it is negative, it would almost imply that a person with an extremely tall father would mostly have a very short son, and that is not realistic whatsoever. Now, near 0 implies that there is no relationship whatsoever, and of course we know through genetics that that is not feasible. If I look at E, somewhere greater than 1.0, the fact that we're using correlation, we know that that range is always between -1 and 1. So somewhat greater than that is not a feasible answer. Exactly 1, we know that there is nothing in nature that is going to be perfect. So that eliminates. So our only true feasible answer would be C. It is not perfect because, as you all can look at some athletes, you can see that they are extremely tall, but their parents are a little bit shorter. So you have some outliers out there, but for the most part, there should be a positive correlation between the father's height and the son's height. Looking at our last particular problem, given a set of ordered pair, we're given that S of X is equal to 2.5, S of Y is equal to 1.9, and R is equal to 0.63. What is the slope of the regression line of Y on X? Now, this is strictly a textbook. One of your formulas that you're given. Remember that S represents the standard deviation of your X values, and your Y S sub Y represents the standard deviation of your Y values. And there's a formula that is on your AP formula sheet that tells us that the slope is equal to our R times our S sub Y over our S sub X. At this point, we would simply multiply 0.63 times 1.9 divided by 2.5, and we would end up with 0.48 as your answer. So, we have 3-hole punch. Actually, your classmate Liz has 3-hole punch. Oh, Viria, you know Liz. She 3-hole punch those. It is important that these mini assessments are placed in your folder, because we will always recycle this information and help you out. I hope you guys have a wonderful day, and we'll see you tomorrow.